Hello everyone. Today I will tell you about my solution in my problem. Uh, this is my problem is on the contest MU IUPC 2025. And before the video, I have to apologize to all of you I if my bad in English because uh, because I'm not good at English. So I have to apologize if there is some inconvenience when you hear or when you misunderstand. So I have to sorry. Okay. My problem is in this context is about problem H. Problem H. Okay. This is an interactive problem, and first I have to tell you about the problem description. I have a hidden k. I have a hidden k, and when with k is in a range from 1 to 1000. K is in a range from 1 to 1000, and k is not shown for you, and you have to find the k. So how to find the k? You have to ask the judge. You have to ask the judge is one an n, the n, an integer n with n is in the range from one to this I don't know how to say this number. Okay, 1 billion and billion. And when you ask the judge about the n, and the judge will tell you A or B. A or B is the answer of this this problem. Is you have two players A and B. A and B. You have two players A and B, and they will alternately take the stone. The stone you have a stone with n with n stone, and s and the A go first, and they will alternately play, and as and at this time when the player get the stone, they will get the S stone from 1 to k. Yeah, and okay, when the player cannot take the stone, they will lose. So the judge will tell you A or B win. Okay, this is a classical of game theory. This is a classical of game theory problem. So the judge will tell you A or B. So you have to ask the judge, and the judge tell you A or B, and you just must ask the judge about 70 query to find the real k. Okay, hope you to understand this problem. I will give you an example. If you have a k is 4, so if you tell the truth about maybe n is 5, so the judge will tell you B, because this game here you have 5 stones, and so A go first. So A in the so first A will take S stone, It can be 1, 2, 3, or 4. So if SE 1, so the B will take 4. So that means B win. If SE 2, so B take 3. So he wins. He wins too. Yes, and when S is 3, S is 4, the answer is still B. So that means if A take any stone between from 1 to K, so B is win. B is the winner. So you have to if you ask the truth and it's 5, that means the truth will tell you B is the winner. Okay, I hope you to understand this problem and how to solve this problem. Okay, based on the classical of game theory, you will have here so if k plus 1 is the divisor of the n, that means if k plus 1 is the divisor of the n, so that means the answer is B. This is a lemma. It is a lemma, and it's the truth. This is the lemma. If k plus 1 is the divisor of n, so that means the answer is B. And in the another case, the answer is A. Okay, it's based on the classical of game theory. So that means if k is hidden, if the hidden k is 39, so if you ask the truth is n is 40, 80, or 120, so all of this answer is B. So that means if you can find the k plus 1, if you find the k plus 1, you will find the k. Yes, that's all. So how to find the k plus 1? You can see that if k is in the range of 1 to 1000, k is in the range from 1 to 1000. So that means k plus 1 is from 2 to 1001. So you have all of this integer is 2, 3, 4, and 5, 2 to 1001. So how to find the k plus 1? You can pick some number in here. So in the first time you can pick 101, 1001, 1000, 999, 994, 98. Yes, and you will find the LCM of all these numbers. You have to find the LCM of all these numbers. So when you have the LCM is largest common multiple. So when you have the LCM, if k plus 1 is a divisor of this LCM, if k plus 1 is the divisor of this LCM, so that means you can find I'm sorry, if k plus 1 is not the divisor of this LCM, so that means 101, 100, 1001, 1000, here all of these will be eliminated from this number. All of them will be eliminated, and it's not all. All of the divisor of this LCM will be eliminated. So if k plus 1 not in the LCM, so that means all of these number will be eliminated, and all of the divisor here will be eliminated because we don't need them. So if k plus 1 is not in the LCM, is not the divisor in the LCM, so you have to find with the rest, and you repeat this process to find the you repeat the process. That means you choose you choose some numbers on this from this set of integer, and you have to ask the query about the LCM. Ask again, and if k plus 1 is not the divisor, so you have to eliminate it, and then process until the k plus 1 is the divisor. So if the k plus 1 is the divisor of the LCM, what will happen? That means if here you can see that a k plus 1 is 40, and if you try to find them to be the primitive multiple, that means 40 is 2 power of 3 multi to 5. So the LCM, if the LCM is equal to 2 power of P2 multiple of 3 power of P3 multiple to 5 multiple power of P5 and so on. So how to find the 40 here? You can say that if 40 is 2 multiple 2 power of 3 multiple to 5, that means P2 must bigger than 3 and P5 must larger than or equal to 1. So when you have the LCM, you have to ask the choose again, the choose again to find the P2, the real P2 is equal to 3. By that you have to find to add the LCM divide to 2. That means you have to add the 2 again about the 2 power of P2 minus 1. If the answer is still B, so you have to add the 2 is about it LCM, but the 2 is power of P2 minus 2. And then ask again if the 2 is power of P2 minus 3. Repeat until the answer is A. Until the answer is A. That means P2 minus S is smaller than 3. That means is E larger than P2 minus 3. So I'm sorry. No. P2 minus S smaller than here. That means that means the power here is P2 minus S plus 1. That means 3 is P2 minus S and plus 1. Yes, repeat as the LCM until you get the answer is A. So you can find here, and P2 minus S plus 1 is the power of here. So you have to find for the prime is 3. So in this case 3 power of 0. So you have to find you repeat the percent of 3. That means the k plus 1. That means the k plus 1 until you repeat the percent. So that means the k plus 1 will be equal to 2 power of Q2 multiple to 3 power of Q3 multiple to 5 power of Q5. Yeah. So Q2 will be equal to 3. Q3 will be equal to 0. Q5 will be equal to 1. Yeah, then repeat the process. So you will find the Q2, Q3, Q5, Q7. Yes, and you will find the k plus 1. So when you have the result, you will find the k. And you can see all of this will just happen in about 70 queries. That's all. So I have to sorry if my bad English. Because I'm not America. So thank you, and you can subscribe to my channel to follow about my videos. Thank you again, and goodbye.